Good day. Welcome to IME webinar. I'm Sil. I'm the multi-product manager. Today we're going to share about evaluate product manufacturability for consumer products. Without further delay, let's start our sharing. So for the coming 30 minutes, I'm going to share with you the types of simulation that's suitable for consumer product design. First of all, as you can see in front of you, there is 3 types of simulation. On the left, we have simulations, or in layman in general, we call it as a finite element analysis, FEA. And then on top of it, SolidWorks also offer computational fluid dynamics. In the product name, we call it as a flow simulations. And last but not least, SolidWorks plastic. For those who are designing plastic parts and you will need to study the plastic injections, yes, this is the right tool that's very suitable to you. And as for consumer products, today I'm going to focus on simulations, the FEA, and plastic injection, which is SolidWorks plastic. And from this webinar, you're going to see what kind of features is very relevant to your product design. First of all, what SolidWorks offer for simulations. What you see on the screen now is all the features that are available in SolidWorks simulations. We have the static analysis, the fatigue analysis, thermal, frequency, optimizations, and so on and so on. So out of so many types of simulations, personally I have filtered up some recommended features that you should use for you to improve better product design. Those in red in color that indicates in the diagram here is the recommended features that will definitely improve your product design. Of course, first of all, we have the static design, which I will always say that this serves as the basic FEA. And of course, as a product designer, as a consumer product designer, the lifespan of the design is important. Therefore, I also would like to recommend the fatigue analysis, and we have the optimizations. Later we come more detail on this part, drop tests, and of course non-linear static analysis. Overall view about finite element analysis. From left, you can see as a designer, we shall start to draft our design in 3D by using CAD software. And then before we send it for calculations, or we call simulations, we will simplify the geometry and then we export out into another program to perform finite element analysis, where it will break it into a small elements. You can see on the third model over here, and from there we put in the assumptions or the boundary conditions, and lastly we get the result here in color, where the color show us different stress value from minimum to maximum. Now this is a typical CAD to FEA product. Now in SolidWorks, what we try to promote is that we want to integrate both CAD and FEA into one, and the purpose is very simple, so that it will save your hassle of moving from one platform to another platform. And when it comes to design changes, which is very frequent for consumer product design, okay, and you have to import and export again, which is very tedious. So here in SolidWorks, what we want to do is that we want to combine the whole process from design to simulations in one simple platform, and this we call the integrated simulations, to quickly identify and solve your product design problem. And as for the FEA, finite element analysis, we treat it as a features inside SolidWorks, which means once you have your design done in SolidWorks, immediately you can make it into a meshing and calculate for the stress deformations or the factor of safety result inside SolidWorks. So let's say you identify the issue and you would like to immediately improve the design. Yes, because you are still inside SolidWorks platform, so what you need to do is just modify your 3D model, and from there the setup will automatically update and you will get a new set of result. Immediately you can compare before and after the design changes. So this is how SolidWorks simulation can help you as a product designer. So I'm going to use an example of consumer parts, and you can see this is a bicycle crank, and I have three designs. So often as a designer we are in a dilemma. So which is the best design? Have a thought about it, and of course it's not easy for us to say, hey, the first one is better, the second one is better, or the third one is simple, is lighter, and this is better. Alright, so in this case, this is how SolidWorks simulation can help us. Okay. So this is one simple example that I'm sharing here, where the simulation is for designer and engineer. So in SolidWorks interface, once the design is done, you just need to define where is the loading point, where is the location that you restrain it, and what kind of materials that you use. Within split second, the software will do a set of calculations and we get a result which is on the right. So the color plot indicate the red color area is high stress area. So as a designer like us, we know how to improve our design. So from here you can see the interactive design and validations, and this is how it can help. Next up, I'm going to share a video, a demonstration video. It's about 2 minutes, so that you have better understanding on how SolidWorks simulations set up, and you will see how easy it can be done inside SolidWorks interface.
Let's look at the first design. Setting up the test is incredibly easy. The first step is to assign our material properties that include the fatigue characteristics. These are used during the analysis to determine the number of cycles each area on the model can last. After setting the properties for the materials, we then add fixtures. The fixtures represent how our part is going to be held for the test. In this case, we're going to lock rotation by holding the bolt connections to the sprocket gear, and also represent the bearing support that acts on the shaft. For our loading, we're going to assume that the full weight of the rider is applied through the pedal to the crank. To represent this, we'll use a load of 300 pounds. It only takes a matter of seconds for SolidWorks simulation to calculate the results. We can see here that the maximum stress in the model is 230 megapascals, which is well below the 275 megapascal material yield. This leads to a factor of safety of around 1.2. We now create a new study to check durability. We specify the study we wish to check, and then enter the ideal number of cycles it should last, along with the loading style. We can see for this first design that the minimum number of cycles it will last is around 1.8 million, which is less than our 7 million goal.
Yes, what you're seeing here is a report generated from SolidWorks. So you can either compile along, or you can just like copy paste the information from this Microsoft into your final report. Isn't that cool? So static analysis is to check for the stress and displacement. Of course, is to avoid failure and to decrease over dimensioning. Of course, at the same time, you also will not forget that it can let us know the factor of safety of the design and give us more insight on how to improve the design. As consumer good, definitely we try to make the design as light as possible, and in this case, optimization is a great feature that you should consider, because by setting up the design scenario, the software will test the parts and automatically optimize the design into the designer needs. Examples, find the best alternative. Let's say we want to reduce time to market, you want to reduce the cost or weight. So this product can calculate and change dimension variable according to our setting. So you can see the rim, the weight reduction is about 34%. And for another, we call it knuckle design, it reduced the weight by 24%. So this is also another design where the optimization is in action inside SolidWorks interface. So the green color column here indicate the optimized design, where the initial design is here. So from this table, we can do a side-by-side comparison and see which design and how many percentage of design improvement that we can achieve. Fatigue analysis, I would say all the consumer product that we sell, we give warranty, right? So let's say I'm giving up 3-year warranties for these parts. So how we define 3 years is just nice enough, or can I give longer warranty, or can I make sure that my design do not fail during warranty period? So fatigue analysis allow us to predict how long will the product last. From here, it allows us to know how to modify the existing design to extend the working life. So what you need to have is the input of unique SN curve for different types of materials, and from the calculations, we can define the total life, the damage, and of course, the factor of safety of the design. So I would say this is a must-have features for product designer. Drop test. Most of the consumer parts go through this kind of calculations. Samples like I have a handphone, and I would like to know if, let's say, it's dropped at a normal human height, how will be the impact onto my phone, right? So to set up a drop test is pretty simple. Just need to define what's the materials we're looking at and how high the height, okay, of the dropping. So from this simple setup, software will do the calculation, and from there we will know the impact result in terms of stress, deformations, and force. And the ability to specify is the drop height, the impact velocity, let's say you abuse it by throwing the products, and the angle of impact. Of course, we have to know if dropping straight or if dropping flat, how will be the impact onto our consumer parts. And of course, the floor we can also define by ourselves, whether it's a rigid floor or flexible floor like wood or concrete, where it can absorb certain amount of energy. So drop test is really suitable for those who are designing handy types of consumer products. Okay, so this is a torchlight casing. So you can see when it hit onto the ground, you can see the contact areas stress started to distribute it from the contact surface to shifted behind. So here we can see what will be the maximum stress that this part will have, and from there we know whether our design is good enough or not. This is also another example of a camera casing, because you want to study the hinge to make sure that when it drops, it's still strong enough to holding both casing together. Okay. Nonlinear study. Nowadays, a lot of consumer parts was replaced by plastic component. Or let's say our consumer parts, we have rubbers, gasket, kind of things. So nonlinear studies is for us to analyze plastic and rubber products, especially on the deformations beyond the use strength, and also can use to simulate large diffraction. So the image on the right, you can see this is some samples of parts that have gone through nonlinear study. Okay. So this is one of the example of hinge. Okay, and this is, let's say, a simple stress loading onto a plastic bottle, and we want to study what will be the deformation of the bottle. Okay, very straightforward. types of analysis. Now, I'm going to stop at the simulations and let's look into plastic injection. Yes. Like I mentioned just now when I explained about the nonlinear analysis, nowadays there's quite a lot of parts are replaced with plastic part, and designers are not sure how good is the design. So let's say when I design a casing, I want to make sure that on the surface of the casing do not have weld line, or it doesn't show any shrinkage, and how would be the maximum warpage of the design so that it works under the condition that we want, at the same time it maintains the product quality. So plastic simulations give us this insight. Okay? It will simulate how melted plastic flow during the injection molding process to predict the manufacturing related defect on parts and the mold, and from here you can quickly evaluate the manufacturability when you design to eliminate costly mold rework. And for your information, if you do changes in the early stage, especially for plastic part, you can save a lot of cost. Imagine if the changes was done before the mold was produced, and you already can predict all the manufacturing defect and perform design changes, then the costs that you need for a mold change is tremendously low. Now, in another round, so let's say if the mold is there, and from the mold testing only you realize the design need to change, then you have to spend more time and more cost on doing the redesign or mold rework, right? I hope you agree with me on this point. So very simple setup, just need to know what kind of plastic material that we are using and where's the injection location, and immediately the software will feedback with us on how the parts will flow in. So this is one simple plastic parts as an example. You can also perform multi-cavity, and the runner that you can see at the center, we have a features called runner balancing, which means let's say it's a family mold, we have the top and the bottom casing, the software can actually automatically optimize the runner diameter. In short, this is all the features that can perform by SolidWorks plastic. We have the filling and short. We can calculate the air trap. If you want to know the weld line and want to make sure that it do not appear on top of the casing, yes. Shrink mark. Okay, I have a customer, they have to use up to 6 months only to realize the design have shrink mark because they have to wait for the mold rework and all kind of things. So if this information known upfront, imagine how many months of time that you can save. Okay. And if your design involves multiple gate, yes, we support multiple gate design as well. Multiple cavity, runner balancing, I mentioned just now. And shrinkage, you want to know during the cooling, how will be the shrinkage from the original design? Yes, it can be done as well. And other than that, it's also other features that supported in SolidWorks plastic. To know more about these two products, you can feel free to later on reply on our survey form. I can always arrange a time to come and visit you and do a live demonstrations, or even if you have a product, you can always give me upfront. I can study it, and from there I can give you some advice what kind of analysis can perform for this product design. So as a summary, SolidWorks simulation is tailored for design engineer to fulfill customer demand. I understand nowadays a lot of customers asking for this kind of simulations, and this is a kind of upfront design validation. This is not just purely about finite element analysis. It's an upfront design validations to reduce expensive actual testing. Of course, optimize your design for weight and performance while at the same time maintaining the ergonomics of the design. Okay, as a consumer part designer, definitely we want to avoid design to void during warranty periods, and it was so simple to use that the current user, you, can see as a features in SolidWorks instead of a complicated new product to learn. So take these opportunities and explore more about SolidWorks simulations. Now we are going for Q&A sessions, so if you have any questions, feel free to type into the question box and we will do our best to answer most of the questions.